Hey, all my favorite mathematicians. Welcome. Again, we're going to find the volume of a solid. So finding the volume, we're going to use a double integral. We are under this elliptical paraboloid, which is above the xy plane, so above z equals 0, and then inside this circle. All right, so let's think about what we're dealing with. We have this paraboloid, and in 3 space, that paraboloid centered at the origin is opening up. I'll go ahead and draw a circle here. So it kind of looks like this. This is what we're dealing with. And obviously that, keeps going up in all those directions forever. So we've got our paraboloid. So we're under the paraboloid, above the xy plane, or z equals 0, and then inside this shape. And this shape is a cylinder. It's a cylinder. So let's think about what this shape looks like, or at least that base region, so we know what to extrude up. So as I've just said, z equals x squared plus y squared is a paraboloid. We sketch that, opens up, and then we have this cylinder, x squared plus y squared equals 2x is a cylinder in 3 space, or a circle on the xy plane. But where is that circle located? What are we being asked to integrate? So we've got V, we have some region R or G, which we need to determine, but the function is going to be x squared plus y squared. That's my upper bound. And then we'll figure out what our x and y are. Or, hey, I recognize x squared plus y squared. That's the same as r squared, a circle. So maybe it'd be helpful to work this in polar coordinates. So what is the region formed by this cylinder? We briefly looked at what that paraboloid was, but the region formed by the cylinder. Well, x squared plus, I'll say actually minus 2x plus y squared equals 0. We could complete that square here for x squared minus y squared. That's x minus 1 quantity squared plus y squared equals 1. When I complete the square and I add the 1, I would add 1 here. So this is a circle of radius 1 shifted to the right 1 unit. So instead of being at the origin, this tells me it's shifted right. That center is 1 unit to the right. We have a circle of radius 1. All right, so we've already kind of acknowledged here that, hey, we want to set this up using polar coordinates. But how are we going to do that? How am I going to set up my r and theta bounds? Well, we're inside this circle, and then this cylinder is extending up. I'll sketch this a little bit in 3 space here. So we've got this circular cylinder here. Try and make that the best I can, which is extending up into 3 space. And so then, as we said, we have this elliptical paraboloid. I'm going to draw it a little wider here just to make it kind of visually make more sense. And we are looking at the region that is inside the cylinder coming up from the xy plane, or the plane z equals 0, to where it touches this elliptical paraboloid. So that intersection there is kind of a concave ellipse, right? So we've got kind of a circle here where they are meeting, and it's concave circle because that paraboloid is curving into it. All right, so let's set this up in polar. I have V. So my volume, if we want to think about polar, what is my theta going to go between? So we have negative pi over 2 to positive pi over 2. So theta is between negative pi over 2 and positive pi over 2. And then I need to determine what my r, my radius functions are between. So obviously, coming out, I need to be touching that circle. So I can have radius equal to 0, which gives me that point right here, or then extending out to touch that circle. So what is that circle in polar coordinates? Now, we have the equation up here, x squared plus y squared is 2x. X squared plus y squared is 2x. So that's the equation of my circle. Well, x squared plus y squared we know is r squared. And then x in polar coordinates is r cosine theta. So I can divide on both sides by r, and I get r is equal to 2 cosine theta. So 2 cosine theta is my other bound. All right. So the function that I'm integrating is x squared plus y squared, which we know, again, is of course r squared. We have our extra factor times r, and then we write dr d theta. So this is my setup to evaluate this integral in polar coordinates. And that's the main point of this video, is to help you see that. This is, at this point, pretty easy for us to integrate. So I'll start you off on this at least. We have we've got negative pi over 2 to pi over 2. And I'm going to integrate r cubed, which is going to be r to the 4th over 4. So I now have r to the 4th over 4 from 2 cosine theta for my r and 0 d theta. So I've got negative pi over 2 to pi over 2. If I plug in 2 cosine theta, 2 to the 4th is 16. So I have 16 cosine to the 4th theta over 4, or 4 cosine to the 4th theta. And of course, plugging in 0, I get 0. So from here, that 4 can go in front, and I would need to integrate from negative pi over 2 to pi over 2 cosine to the 4th theta d theta. At this point, I would say, I don't want to have to write negative pi over 2 to positive pi over 2. And since I know this is symmetric, I can say 0 to pi over 2 and double that coefficient in the front. So I cut my interval in half and I double my integral value. And at this point, we can reduce this using double angles. So we would use those. Cosine squared theta is 1/2 1 plus cosine of 2 theta. And we also have a similar one for sine. So we go through some reduction processes to reduce this and simplify this integral. Now, this is something we learned how to do in Calc 2. We should feel confident doing this. And for the sake of not making this video take a really long time, I'm going to do the favorite thing that my grad school professors would do. They'd say, well, and clearly the answer is 3 pi over 2. So some intermediate calculus in there. Now we have our answer, 3 pi over 2. So you guys should be confident finding that integral at this point. All right, so I hope you have a better feel on how to take these rectangular coordinates and use them in polar coordinates, because coming up, we're going to talk about cylindrical coordinates, which, again, cylindrical, polar, probably going to help us with that. All right, you guys, have fun, be safe, good luck. Email me if you have any questions.